Welcome to first order linear differential equations. So we'll have a series of definitions here. First up, a differential equation or a first order linear differential equation is an equation that can be written in the form y prime plus p of x y is equal to f of x. So in other words, there's no products of y or its derivative involved. We say the equation is homogeneous if f of x is identically 0 So in other words, we have y prime plus p of x y is equal to 0 is our equation. Otherwise, we say the equation is non-homogeneous. Oops. So for some quick examples of homogeneous and non-homogeneous first order linear equations. Y prime plus 7x squared y equals 0 is a homogeneous first order linear differential equation. I'll actually write it out 1 moment. So it's a homogeneous first order linear differential equation. Similarly, y prime minus cosecant x times y equals tangent of x this is a non-homogeneous first order linear differential equation. We can also write these in a slightly different form. If we have x y prime plus 2y equals 3x minus 1. This can be rewritten. This is equivalent to y prime plus 2 over x times y is equal to 3x minus 1 over x. So this is also non-homogeneous. First order and linear. So they don't have to be originally written in the sort of standard form of y prime plus p of x times y equals f of x, but they have to be able to be rewritten in that format. So just a quick note, note that homogeneous first order linear differential equations are separable, which means we already know how to solve them. So in the next video, we will go ahead and take a look at a non-homogeneous, or sorry, at a homogeneous example. And we wind up getting a pretty straightforward process because these are a very specific type of separable equation.